So linear inequalities, you have two variables, x and y, and they're related with some kind of inequality sign, less than, greater than, less than or equal to, greater than or equal to. And so what we're going to be having in this case, instead of when we do it on a number line, we would have an open dot or a closed dot to determine whether it included the point or not. When we graph a line then, we're either going to use a dotted line or a solid line to determine whether it includes it or not. All right? And that line is called the boundary line. So you can see from this right here that they show the boundary line here, and that the side over here, this is the line, the boundary line is the line y equals 2x minus 4. The blue shaded area is where y is greater than 2x minus 4, and the green shaded area is where y is less than 2x minus 4. And so usually the case is that if it's greater than, it's going to be above the line. Okay? So over here it says the blue part is y is greater than 2x minus 4. And because the way the line is slanted, we would say that's above the line, greater than. And the green area here is less than, and so that would be below the line. So we're going to look at graphing linear inequalities. So first we're going to graph y is greater than negative 1/3 x plus 2. So now since it says it's greater than, that means that we're not going to include the line. So when I draw the line on my paper, then I'm going to make it a dotted or dashed line. So here we've got our y-intercept. Our y-intercept is 2. And our slope is negative 1/3, so we'll go down 1 and over 3. And now when I draw my line here, I'm going to make it a dotted line. So we draw the line, y equals negative 1/3 x plus 2. Since it says greater than or less than, that means we're going to make it a dotted line. Now it's just a matter of determining which side of that line are we going to shade. If it's greater, it's above. If it's less than, it's below. But we're going to check it just to make sure we're right. Okay? What would be a really good point, an easy point to use to check to see if I'm correct or not? Okay, the origin would be, okay, 0, 0. So I'm going to check to see if it's true or false for this point here, 0, 0. So I'll put 0 in for y, 0 in for x, and see if it's a true statement. So is 0 greater than 0 plus 2? So is 0 greater than 2? No. Since it's false on that side of the line, then it would be true on the other side of the line. So I'll shade the other side of the line. Oh, no, let's use crayon. So then I shade above the line. And that would be my answer. Okay, letter B, y is less than or equal to negative 1. So is this going to be a solid or a dotted line? Okay, it includes it because it says less than or equal to. So that means I'm going to do a solid line where y equals -1. Now, is that horizontal or vertical? Is y equals -1, is that a horizontal line at -1? Or is it a vertical line? Okay, this is a horizontal line. Oops, not a dotted one though. Okay. And less than would be above it or below it? Above or below? Okay. Okay, so we'll be graphing lines and shading. Okay. All right, let's look at example 2. Now, if the equation of the boundary line is not in slope-intercept form, as in this case here, 3x plus 4y is less than or equal to 12, then you have two options. You can either find the intercepts, or you can put it in slope-intercept form to be able to graph it, first of all. And then in this case is where we're definitely going to want to use this test here by using the point 0, 0 if it's not on the line to see if we want to shade above or below. Because in this case, because it says less than or equal to, you need to make sure you pay attention to that, because depending on whether y is positive or negative, depends on whether you shade above or below. Okay? So you have to be careful. So to do this one, let's find the intercepts for this one. Okay? And how do I find intercepts again? Okay, put 0 in for x and 0 in for y, first of all. Okay, so we're going to find our intercepts. So find the y-intercept first. And all we need is equal signs here. We don't need the inequalities. So if we have 4y equals 12, so y equals 3. That's our y-intercept. Then our x-intercept, we'll let y equal 0. So we get x equals 4. So we mark our intercepts, y-intercept at 3, x-intercept at 4. And are we going to have a solid or a dotted line? Does it include the line? Is there a less than or equal to? Okay, it's or equal to, so that means it's going to be a solid line. So we draw the solid line. Make sure we have our arrows. Now, is this shading going to be above or below? Well, it says less than, right? So I would think it's probably going to be below. So let's make sure, though. Let's put in 0 for x. and 0 for y. And the nice thing about using zeros is when you multiply by 0, you get 0. Okay? So here we have 0 is less than or equal to 12. Is that a true statement? Okay? Okay? It is. So since it's a true statement, below the line with the origin, then I'm going to shade that area. Nice and bright. Okay. So you should always check a point just to make sure anyways. Let's get one more. Oh. Okay, here's a graph, and they want us to find the inequality for this graph. So when we write the inequality for a graph that we know, we are going to write it in slope-intercept form. So we're going to put it in the form y is less than or equal to greater than or equal to mx plus b. We just don't know what the inequality sign is going to be that goes there. We should be able to determine it right away, though. Okay. So this is just like if we were writing the equation of the line. So what's the equation of this line, first of all? Do we know the slope, and do we know the y-intercept? Okay. We can find them, can't we? Yeah. All right. So y-intercept's usually the easiest. What's the y-intercept here? Okay, positive 3. So we have a plus 3 here. All right. To find the slope, is the slope going to be positive or negative? If the line is going up to the right, it's positive, correct? Okay. So I'll find 2 points. I can see where they're at. Here's one. Here's another one. So what's the slope? We have to go up 2 and over 1, right? Okay. So the slope would just be 2. So the equation of that line is 2x plus 3. But what inequality sign goes there between them? Okay, it's shaded above, right? Okay, since it's shaded above, then that would be greater than. Since the line is dotted, there's not an equal to, so this would just be y is greater than 2x plus 3. All right. So you guys do this one here. So in this case, even though it said greater than, we shaded below. It says 3x minus 4y is greater than 12. So let's solve for y and see what happens. Okay. What do I do first to solve for y? Okay, we're going to subtract 3x. So we get negative 4y is greater than negative 3x plus 12. All right, I want to write it in that order, mx plus b. Okay, then what do I do? Okay, so we're going to divide by negative 4 then. So we get y, and when you multiply or divide by a negative when you're doing inequalities, what happens to the inequality sign? Okay, it switches. So instead of it being greater than, It's going to be less than negative 3x over negative 4 is a positive 3/4 x, and 12 divided by negative 4 is negative 3. So it's not greater than. When we solve for y, it becomes less than because of the negative, so you have to pay attention, and it's important then to check a point, whether it's 0, 0, or any other point. You should check it to verify that you're shading the correct side. Okay. All right, one more. And we're not going to use the calculator stuff there. Okay, so here we have a little bit more sophisticated one that we're going to do. And a little reminder over here that what we just talked about, that if we multiply or divide by a negative number, we have to switch the direction of the inequality. So this asks us to solve for y first and then graph the solution. So we're going to solve it for y, so we're going to get it in slope-intercept form and then graph. So Dylan, what do we do first?
You gotta distribute.
Distribute the 3/4?
Yeah.
Okay. Natalie, can I do something else first? Just can't get anything past you, can we? Okay. All right. How many of you would distribute first anyways? You see that and you're going to distribute. Okay, so we'll go ahead and do that. Okay. But you could actually, we could multiply both sides by 4/3 first to get rid of that fraction. Okay. So we could do that. All right. And it's up to you. It doesn't matter. You can do it whichever way you want. Will they both get us the same place? Yes, if we do it correctly. Okay. So we'll distribute the 3/4 because that's what you want to do. So when we distribute the 3/4 times 8x, we get 6x minus 3/2 y is greater than 6. So in this case, either way, we're going to end up multiplying or dividing by a fraction anyhow. All right, so 3 times 8 is 24, divided by 4 is 6x. And 3 times 2 is 6, over 4 is 3/2 y. Okay. So if we're solving for y, what's our next step then? Okay. All right, we got to get rid of the 6x, so we're going to subtract 6x from both sides. So we get negative 3/2 y equals negative 6x plus 6. Okay, so now we need to get rid of this negative 3/2. Oops, it should be greater than symbol, not equals. So we're going to get rid of this negative 3/2. So that means we can divide by negative 3/2, or we can do what?
Or you can we'll change it to a mixed number.
No, that would make it worse.
Yeah.
Okay. All right. So you can either, when we're dividing by a fraction, that's the same as multiplying by the reciprocal. So we're going to multiply by negative 2/3 both sides. So we get y is, well, we multiplied by a negative, so I have to switch the direction. We're now talking about less than. Let's see, 6 times 2 is 12, and 12 divided by 3 is 4. So we get positive 4x and negative 4 then. Okay. Negative 6 times negative 2/3 is a positive 4. Positive 6 times negative 2/3 is negative 4. Okay. So we have a y-intercept of negative 4. And a slope of 4, so that means we're going to go up 4 and over 1 from there. And I've seen you guys do this, so if you, I'll put another dot up there to make sure my line is correct. Go up 4 more and over 1 more. Okay. And is it going to be a solid or dotted line? Solid or dotted? Okay, it just says y is less than, so it's dotted. Am I going to shade above or below? Okay. According to my answer, I'm going to shade below, right? Okay. Now, I should make sure, though, correct? Because we did a lot of work there, and the chances for a mistake are there. But let's just verify it by testing our point. Let's test out 0, 0, see if it works. So 3/4 times 8 times 0 minus 2 times 0, is that greater than 6? Well, we know inside the parentheses we have 0, and 0 times anything is? So is 0 greater than 6? No, that's false. So the origin is on the above the line, so then my answer is going to be below the line or on the right-hand side, whichever way you want to look at it. Then I would have shaded that side of the line if it was true. Okay. All right, questions?